You are listening to the Vocal Technologist. Spoken tech for your ears.
Welcome back. We have so much to get through today, all centered around data. But this isn't just about databases anymore. It's really about building intelligence.
That's the absolute core of it, yeah. The foundational assumption of who, or maybe what, the primary user of enterprise data is, it's just completely changed.
Right.
We're past the point of optimizing for a human looking at a dashboard. Now we're building systems for AI agents, for autonomous entities.
And that shift just changes everything, the entire engineering blueprint. So our mission today is to really dissect what it means to build data systems for the agentic AI era. Because if you're in the data world, the old roadmap is, frankly, obsolete.
And the new requirements are incredibly high stakes, but also, I think, completely fascinating. Let's start with that fundamental mandate change. Data engineering isn't just about moving and storing things anymore.
Okay, let's unpack that. If we look at the single biggest shift, it's this move away from the traditional ETL pipelines, the ones aimed at human reporting. So what are teams building now? What's the new output?
They're building what are being called context systems. We have to think way beyond the relational table. To support any kind of, decision-making AI, these systems need to provide really rich semantic metadata data provenance.
So knowing exactly where the data came from.
Exactly. And, critically, high-quality vector embeddings to actually capture meaning. We're not building reporting tools anymore. We're building the intelligence fabric of the company.
And this isn't some far-off theoretical thing. The scale we're talking about is already here.
Oh, it's happening right now. The evidence suggests that AI agents are fast becoming the main machine users of data.
Right.
We're seeing estimates that agents are driving, over 80% of new database creation in some organizations?
Yeah.
And the volume of analytical prompts, the requests hitting these platforms is just surging. That's the new baseline.
That brings up context graphs, which really stood out to me. I want to spend a second here because this isn't about static historical data. This is about capturing the messy reality of how a company works.
Exactly. A context graph is, in essence, a dynamic, living map of how work actually gets done. It captures real processes, the implied relationships between tasks, and all the activity across your enterprise tools.
Your CRM, your ticketing system, Slack, all of it.
All of it. So if a human analyst might just intuit that task A usually follows task B, the context graph explicitly maps that out.
And by learning those patterns, an agent can automate incredibly complex tasks.
Precisely. It learns the repeated steps, the dependencies, and it can then replicate them reliably. The data platform shifts from just storing information to actually understanding and replicating operational reality.
Which is obviously essential for any kind of safe automation. And this idea connects directly to the need for a really robust semantic layer, especially if you want reliable conversational BI.
Absolutely. The semantic layer is like the Rosetta Stone for the AI. It has to be shared, and crucially, it has to be independent of any single BI tool.
To avoid creating another data silo.
Right. You need a single source of truth for definitions. What's really interesting is how this is being automated. You have tools like Dealt for automatic schema discovery, and you can even have LLMs draft the initial data models.
Okay, wait a minute. If an LLM drafts the model, how do you make sure the output is reliable? That sounds like a recipe for, non-determinism.
That's the key safeguard. You automate the drafting, the initial setup, but the underlying queries that the semantic layer generates, they have to remain 100% deterministic and debuggable.
Okay, so you use the AI to speed up the modeling, not to inject ambiguity into the actual results.
Exactly. So let's shift to the infrastructure. This is where this scale just gets wild. How are these massive companies actually handling petabyte-scale recommendations and all the complexity of vector embeddings?
Yeah, the how.
We're seeing a lot of maturation in key architectural pieces, especially vector embeddings in feature stores. Take Expedia Group. They needed a central place to manage all these vectors.
The numerical representation of their data?
Right, so they built a centralized embedding store by extending an open-source tool, Feast.
Which is smart. They built it into where their feature management was already happening instead of, building a whole new system from scratch.
It's a unified approach.
Okay.
It adds the vector database capabilities you need for management, versioning, querying, and it supports both classic similarity searches. Show me things like this.
And also hybrid searches?
Exactly. Hybrid searches that combine that similarity with traditional filters, which lets an agent ask much more nuanced questions.
And then there's the scale of the models themselves. I mean, looking at generative recommenders, the Netflix case study is just Staggering.
It really is. They scale their models from 1 million parameters up to 1 billion. They process 2 trillion tokens for training.
That's an incredible number.
And think about this. Their item catalogs were up to 40 times larger than the training data used for something like GPT-3. The engineering challenge is just serving those recommendations efficiently in real time.
So what were the big breakthroughs that made that possible?
They had to find ways to just slash the computational load. A key one was sampled softmax.
Right.
So imagine you have a warehouse with 1 million items. Instead of checking every single shelf for a product, you only check the 20 most likely aisles. Sampled softmax does that for classification. It approximates the probability without calculating every single possibility.
That makes sense. And that, combined with things like multimodal semantic towers, made it feasible.
It's a massive engineering lift. And when systems get this complex, keeping them up to date is its own headache. Which brings us to change data capture, or CDC, with systems like Iceberg.
Which is critical because agents need that real-time data to be accurate.
Absolutely. And with CDC into something like Iceberg, you have these key trade-offs. The simple path is just to write changes directly, but you have less control, fewer recovery options.
So what's the better, more robust way?
You maintain a raw change log. It's more complex architecturally, sure, but it gives you so much more flexibility for replaying events, for recovering from errors.
I assume at scale, that simple direct write approach just falls apart.
It does. Your read performance would just degrade until the system collapses. You have to use techniques like merge on read and regular compaction. It's essential.
It all sounds incredibly complex, but the standard for customer-facing systems is zero downtime. The Salesforce migration story is just a perfect example of this.
It really is. It shows operational excellence under extreme pressure. Their marketing cloud did a zero-downtime migration from Memcache to Redis cluster.
And this was while supporting 1.5 million cache events per second, live.
Live traffic across dozens of critical services. And the performance metric is the real jaw-dropper.
The P99 latency.
They maintained end-to-end P99 latency at a blazing fast 20 milliseconds.
Just to anchor that for you, listening. P99 means 99% of those 1.5 million requests every second were served in 20 milliseconds or less.
That isn't just fast.
No, that is continuous operational continuity. Because if that latency spiked to, say, even 100 milliseconds, automated systems that rely on that cache would just start failing. That's why that 20 merits figure is so vital.
It proves you don't have to sacrifice performance, even during a major overhaul.
All right, let's pivot from the successes to the inevitable pain points. This exponential growth has created what many are calling a hidden cost crisis.
The stakes feel that high, because they are. Cloud bills are exploding. It's from a fundamental lack of governance, poorly optimized queries, redundant storage, the same data copied across 5 different services.
And rampant over-provisioning.
Right. And the cost isn't just the bill. It's the human cost, the engineering time.
Yeah, the opportunity cost.
Exactly. Data engineering teams are spending up to 60% of their time just on maintenance, just keeping the lights on, instead of driving new value.
But there is a way out.
There is. The organizations that are implementing really aggressive governance, proactive data pruning, right-sizing clusters, they've been able to cut their infrastructure spend by 40 to 60% in a single quarter. Governance is a core feature now.
Okay, let's talk reliability. Machine learning drift detection. You've got these powerful models making decisions, but the world changes, so the models decay. How do you keep them reliable?
You have to have continuous monitoring for 2 main types of drift. First, there's data drift. That's when your input data itself changes. Maybe your customers just start using a product differently.
And the second type?
That's concept drift. This is more subtle. It's when the relationship between the inputs and the output shifts.
Okay, give me an example.
Imagine a model trained on shopping habits before a major global event. After that event, people's fundamental motivations for buying things have changed. The old logic is now flawed. That's concept drift.
So how do we catch these shifts before the model starts making just awful decisions?
You start with simple univariate metrics, like a Kolmogorov-Smirnov test on individual features. But for the complex stuff, you need multivariate approaches.
Yeah.
Autoencoder-based reconstruction error is becoming really common.
Okay, that sounds pretty technical. Why an autoencoder?
So an autoencoder is trained to compress and then accurately reconstruct its input data if the model starts getting data that's really different from its training set.
Because of drift.
Because of drift, the autoencoder will fail to reconstruct it accurately. That high error rate is your alarm bell. And it's critical when you don't have the ground truth, the final correct answer, available right away.
That's a really clever way to spot the unknown unknowns. Okay, the elephant in the room. AI agent security. If agents are running workflows touching critical systems, the attack surface has just exploded.
It really has. You're not just securing an API anymore. You're securing the whole chain of tools and communication the agent uses. This is why standardized frameworks are so important, and Safe MCP is the one to watch.
Safe MCP, adopted by the Linux Foundation and OpenID, what does that do?
The MCP part is Model Context Protocol. It basically standardizes how models talk about their context and intentions. And the SAFE framework provides this actionable MITRE, ATT, and CK style guidance for this new world. They've documented over 80 specific threat techniques.
And what kind of attacks are unique to agents?
Well, think about prompt manipulation, where you trick an agent into doing something it shouldn't. Or tool poisoning, where you compromise one of the agent's own functions so it executes malicious code thinking it's doing a normal task.
That's a pretty sobering list. But let me throw a wrench in the complexity machine here, because sometimes the simplest solution is the most elegant one.
That's a great point. A lot of enterprise AI projects over-engineer structure way too early. They try to classify and label everything before they even know what they have.
And the practical detail here, which I think you, our listener, will appreciate, is brilliant. Just store the messy natural language explanations. Use a text box.
Right. Why force a rigid classification on a business process description? Store the why we did this in plain English, and then let an LLM classify and summarize it later. OpenAI did this internally on over 1 million conversations.
It lets you move so much faster without sacrificing future accuracy. This is the Vocal Technologist, and we're going to close out with a quick tour of some fun nuggets that just illustrate this new operational reality.
Yeah, let's look at how people are solving problems fast.
Okay, nugget 1, internal analytics. MotherDuck built an internal wrap for their employees, a summary of their yearly activity using simple SQL on existing usage data. It took about an hour. It just proves that great analytics comes from good data hygiene, not a million-dollar tool.
Insight 2 is on new runtimes. Bun, the JavaScript runtime, introduced a unified SQL API for a bunch of databases with 0 dependencies. The result, 60% faster build times on macOS, lower memory usage. It's a straight-up productivity boost.
And this next one is a lifesaver for anyone validating production deployments. The CLI table diff. It just quickly compares 2 database tables to find missing or mismatched rows. It works across different engines like DuckDB and Snowflake. Super fast, super simple.
And then we saw Databricks built an internal AI agent for debugging their own database instances. It allows conversational interaction with logs and metrics, and it's reduced their debugging time by up to 90%.
90%. That is a massive game in getting things fixed. And finally, the Cloudflare 2025 look back just confirms everything we've been talking about. Global traffic up 19%, Starlink traffic doubled, and AI crawling just surged.
And here's the key metric. Non-Google AI bots made up 4.2% of all HTML requests globally. Agents are not just in your internal databases, they are aggressively consuming the public web.
Right, and post-quantum encryption hit about 52% of human web traffic. We're already quietly prepping the web for what comes next.
It just shows that engineers are solving these problems on the bleeding edge, often way before the standards catch up.
So to wrap this up, we have moved from building data warehouses for humans to building these context systems for autonomous agents. The mandate is no longer just reporting. It's reliable, safe, governed automation.
And for you, the person learning this, the new expertise, isn't just knowing SQL, it's understanding the connections between the data, the operational context from those context graphs, and the security frameworks like Safe MCP. Synthesizing those 3 is the next big thing.
That is a perfect synthesis. But let me leave you with one final provocative thought to chew on. If context graphs truly capture the reality of how a company operates, all the messy, hidden, maybe even toxic workflows that people fall into, then the next major data failure won't be a missing table. It'll be an AI agent perfectly executing a toxic workflow it learned, but at 10,000 times the speed. How much autonomy are we really ready to grant a system that understands our own messy processes better than we do?
That's a critical question for the future of work.
Indeed it is. We'll be here to unpack the answer when the data comes in. Until next time.
Spoken Tech for your ears.